Oh, it's 8:55.
Yeah, it should be good.
All right. Okay. Well, welcome everybody to this satellite session of the ACA. This is the Cochin Seminar in Differential Algebra, and well, we welcome you to New York City, of course. And today we have our first speaker, Markus Rosenkranz from Kent University at Canterbury, right? Markus is going to give us, as you know, a series of talks on a very, very new area, which I would still call differential algebra, if you don't mind.
Okay, I'm happy.
But actually, it's a very breakthrough, I think. In fact, this breakthrough, it's so new. In differential algebra, we have been using algebraic methods to look at differential equations and to study the properties, and even to derive algorithms to solve, especially in the linear case, whether it's linear ODE or linear partial differential equations. But we have never, very seldom until recently, to look at problems that involve initial value problems and boundary value problems. Now, in the first paper on initial value problem using algebraic methods, I think it's actually a paper of myself and Pritchard, Ian Pritchard, that we started in 1998, but the paper was published in 2000 something, actually a little late, because it's unconventional, I think, in some sense. We use Grosvenor bases and things like that to attack the problem of initial value problems, and about the same time, about 2004 or something, 2002 actually, right?
Yes,
That Markus started doing his dissertation and introduced boundary value problems and treating them in an algebraic way. And he's now, of course, combining both initial and boundary value problems in different algebra, treating them totally algebraically. And this is also due to another branch of differential algebra that is starting to becoming, well, I won't even call it mainstream, but starting. And this is on what is called the Rotor-Baxter type algebras, and also the differential type algebras that we kind of discovered from computers. So we have a uniform method to treat these things now. So these are different varieties of differential algebras, not the usual differential algebra. Of course, it's covering the usual differential algebra and difference algebra, but more, and which has application in all sorts of mathematics. So I want to welcome Professor Rosenkranz here to give the first talk, which is on integral differential polynomials and 3 integral differential algebras.
Thank you very much. Yeah. Thank you for this nice and, in fact, embarrassingly nice introduction. I would not call it a breakthrough yet. I would say it's the first modest attempt at approaching boundary value problems, initial value problems through or starting from differential algebra. So I myself would consider it an honor if it is counted as part of differential algebra. So thank you for this opportunity of giving really a comprehensive summary of my work on that today and tomorrow. So today, the first talk is not an introduction to the general methodology of boundary problems, mainly for organizational reasons, because this is a 1 hour time slot and I wanted to have more time in the afternoon for the talk on boundary problems. So that's maybe a slight didactical disadvantage that I'm starting off with this one here, but I will give the necessary introduction also here. Okay, so just a short overview that